Okay, on this graph, we have a force versus position of how much a rubber band is stretched, and the rock is shot out of the rubber band like a slingshot, and they want to know the speed. So there's two ways of doing this. Again, on a force versus position graph, we can find the work done or the energy transferred by finding the area, excuse me, on that graph. So we would have the work done, and that would transform into kinetic energy. It's one way to do this. So the work is going to be 1/2 the base, which is 0.3 meters, times the height, which is 60 newtons, will equal 1/2 mv squared, which would be the kinetic energy. So when we look at this, it's going to be 1/2 so this will be 9 joules is equal to 1/2 mv squared. The second way of doing this is looking at this with including the spring in your system and going from spring potential energy to kinetic. So spring potential energy would be 1/2 kx squared, where k is a spring constant. And given that graph, to find, if you found the slope here, that would give us the spring constant, which would be 60 newtons over 0.3 meters, or 200 newtons per meter. Set that equal to 1/2 mv squared, we would get 1/2 times 200 newtons over meters times 0.3 meters squared. Again, you would end up with 9 joules is equal to 1/2 mv squared. So when we substitute everything in to determine the speed of the rock, we end up with